Welcome back, students. The given objective in the syllabus was sensor interface for displacement measurement. We are supposed to measure how much distance a particular robot or some object has moved. So a small change we have made in the objective. We are going to measure the distance between two objects or the device, sensing device to the object. So for this, we are going to use an ultrasonic sensor. The aim is to measure the distance between the obstacle using the ultrasonic sensor. And what is ultrasonic sensor? Do you all came across this? Have you people came across this ultrasonic sensor? What is this ultrasonic? High frequencies. High frequency sound signal. Okay, using this high frequency sound signal, just like how bat detects, and how dolphin or this whale, these things use this ultrasonic sound to detect the objects and detect the obstacles. The same kind of technology is used to uh, identify some obstacles before a robot or a vehicle, like that. Okay, so what here it does is it transmits. This sensor contains two things. One is transmitter, another one is receiver. Transmitter is basically a speaker that generates sound in ultrasonic frequency, and receiver is a mic similar to mic. Okay, these two sensors, two devices uh, are the parts of this ultrasonic sensor. So when a sound wave is transmitted, it travels in the air, and when it hits on some target, it reflects back, as this a graphical illustration says. So here the sound wave travels, and when it hits and it reflects back, the reflected sound is being recorded or observed in the mic or the sensor receiver. So how to measure the distances? If the distance between the target is reduced, if the target is too close, the sound wave will be reflected fast back to the sensor. If the obstacle or the target is away from the sensor, then the sound wave will take a long time to get back to the sensor. So that is the basic principle of this ultrasonic sensor. So here you can see the flight time is the time taken by this. The flight time is the time taken by the sound to travel from the source to the target and get back to the sensor again. So it is traveling and getting back. It takes 2600 and sorry, 2610 microseconds for from the time it is originated from the speaker or the transmitter, ultrasonic transmitter, and it goes to the target and gets back to the sensor again. So this is the total time of the sound it traveling in the air. So they call it as time of flight. And here the speed of sound in normal room temperature, it is approximately uh, um, it travels 1 centimeter in 58 microseconds. And if with these two values we can calculate the range or the distance between the obstacle and the sensor. So time of flight divided by the speed of sound will give you the distance between that. Okay, so 2610 microseconds is the time of flight divided by the speed of sound gives you the distance. So here the distance is 45 centimeters. So this is the underlying principle or underlying concept or formula we are going to use for our calculation. So this is the circuit we are going to use. What we are going to do now is same as your previous program. In previous program, what you did, if the temperature is in particular range, one LED will be glowing. If the temperature is in the next range, then next LED will glow. If the temperature is too high, then the last LED, all three will be glowing. This is the way you have constructed the fifth experiment, isn't it? The same way, if the obstacle is too close, all the LEDs have to glow. If the obstacle is somewhat away, the two LEDs will be glowing. If obstacle is somewhat away from the sensor, then only one LED will be glowing. If the obstacle is too far from the range of the sensor, then no LED will be glowing. So that is the idea we are going to implement in today's lab. So I have connected the power supply. This ultrasonic sensor is a ready-made module available in the market. It has VCC power supply, can you see? VCC and ground. So these two have to be given to the power supply, 5 volt and ground of our Arduino board. And trigger and echo. Trigger is for transmitter. Here you can see T. This part is the transmitter and this part is the receiver. So a sound will be generated, ultrasonic sound will be generated in this, and the reflecting sound will be observed or received in this. So this is the receiver. And so here trigger and echo. So if I want to initiate some sound, so I have to give logic 1 in trigger, and if I want to observe something, then I have to read it from echo. Now we will move on to the next. So this is the basic hardware setup. Now I am connecting this pin number 7 to the trigger. So if I want to trigger this transmitter, I have to send logic 0, logic 1, logic 0, like that. I have to make this pin high and low, same way we turned on and off the LED. Do you remember the first experiment? We turned on and off the LED, a digital output. The same way we are going to turn on and off this trigger and read this echo signal. How long this echo signal is on, that is the time of flight. So that we can do it very easily in the Arduino using C program. So pin number 7 is trigger. Please make a note. Pin number 7 is a trigger and pin number 6 is the echo signal. And here we use 3 more output pins to indicate the distance. Pin number 2, pin number 3, pin number 4 are respectively used for 3 LED connections. So now next thing is how to write a program for this. We have to measure the how long this echo signal is high. That will give the time of flight. This is the echo signal. For example, it is on for some duration. This duration, if I can find, then that is the time of flight duration. So that is what we have to find. For that, there is a inbuilt function in the Arduino C. We have an inbuilt function in that. It is a pulse ln. Pulse and inside that function we have to pass this pin number, in which pin number I am going to observe. Here the echo is pin number 6, so I have to put 6 over here, and the value, what is the value I have to measure is, if I'm going to monitor a logic high, the duration of a logic high or logic low, that I have to specify here. The usage example is this one. So this function will return the duration of the pulse. It's that signal being high. So how long it is high, that duration value will be returned. So it will be in long integer. So we have to use a long int function. What is the application? In car parking, reverse parking, you have sensors. If there is you can also use this for measuring the water level in your overhead tank in your home. You can use it for obstacle detection. You can use it to measure the distance between your in the robot. All those things you can do with this um, ultrasonic sensor based projects. So now, how what is the program and what is the construction? We have already seen the construction of this. The um, circuit diagram we have discussed. Now the coding part. The coding part here, I initialize a variable with a centimeter. Centimeter, I have given a name. It's a displacement or distance. Okay, distance is what this the final value. So it is initialized as long because the value is going to be in a fractions or it will be large value. So it is initialized as in long and value with 0, initial value with 0. And here the actual setup is we need serial communication to see the value what is being measured by this ultrasonic sensor. So I'm going to use a serial communication. So serial communication in the baud rate of 9600. This is the usual thing we used to do, and we use this three pins, pin number pin number 234, 234 as the output for this LEDs to indicate the distance. And in main loop, this is my main loop. In my main loop, I call a function. This is my own function uh, that that we write for our custom use. Uh, and here we read the value. So when this line statement 14 is being executed, what will happen is it will go to the function, this function, and this function statements will be executed. What this function is saying is, first turn on the trigger pin mode, the output. It is triggering the trigger pulse of the ultrasonic sensor. It is making it low for 2 microsecond and making it high for 10 microsecond and again making it low. So, and we are observing observing the echo pin. Echo pin is the pin number 6. Pin number 6 is observed. So, and what is this value we are multiplying? If you put it is 58. Okay, 58 is the speed of sound. So with that we multiply that. So to convert, as in this PPT slide, we saw the conversion, the formula that we perform, and that value we return to this main loop function as the displacement. So that same I'm printing in the serial port, and I make we have initially we have made a thing like we have to indicate it in the LEDs. If the distance is above 250 centimeter, then all should be, it is out of range. If it is between 250 centimeter and 170 centimeter, then one LED should go glow. If it is between 175 and 100, then two LEDs should glow. If it is less than 100, then all that means the obstacle is very close. So this way we put a if statement, if statements to switch between the ranges. So the same code is what expected in the previous session also, previous experiment also. The same kind of code you can use for indicating the temperature there. And so this is some kind of calibration thing we do. And here again I repeat, we trigger the circuit here, trigger the ultrasonic circuit, first low and then high and then low. After that, the sound is being traveling in the air. and we are monitoring this echo pin, and we are finding how long the echo pin is high, and we are multiplying with the speed of invert factor of the speed of sound, and returning the value to the main probe loop. And in main loop we are printing it in the serial communication, and we are making the decisions to blow the LED in for different cases. So shall we go for a simulation? Here, if you start, okay, if you click on the sensor, same as your temperature sensor, you can see the operation of this temperature sensor. The green color one is the range of this sensor. If this ball is inside this green color one range, light green space, then it can detect the obstacle. And as soon as you can see, the as the distance changes, this dark green one is the obstacle. The sound is traveling, hitting on the obstacle, getting back to the receiver, transmitted, hitting on the obstacle, getting back. So if it is too close, the sound reflected will have a shorter length of on time, so that that timing we are calculating, and we are we measure the distance using that. So if it is far away, you can see the LEDs turning off, and if it goes out of range, all the LEDs turns off. So here, if you want to add breakpoints, have you used breakpoints in your program? Just click on this numbers and start the simulation. Your program will come and stop over here. Your program execution is an infinite loop. It will run, but it will stop over here. That, and you can use this to switch between the cases, or you can execute it, or you can stop the program at any point you want, and using this play button, again you can resume the execution. You can add, for example, I'm adding a breakpoint over there. It comes and stops over here. This way I can make, for debugging we use this breakpoints, like uh, because if the program execution, it will happen in a fraction of a second, it will execute all the statements, but we can't find where the program is getting unpredictable. So I can add a breakpoint over here, and I can add a breakpoint over here, 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 like that. I can add breakpoints and make it execute. So if it is getting into this loop, then this loop is being executed, we can tell. And that's all for this program, and the slide for this presentation will be shared, and these are the reference materials I have referred for this class. That animation was taken from this website, and the entire project was followed, or from this instructable website. And uh, for further reference about the pulse in uh, function, referred this Arduino website. And that's all with this session. See you on the next video.